A synchronous binary counter is a sequential logic circuit where all flip-flops are triggered by the same clock signal. At the beginning of the design, a state machine is created. If the input is set to 1, the circuit should count from 0 to 3 and then start again at 0. If the input is set to 0, the circuit should stay at the current state. The state machine is converted to a state table from which, with the help of K-maps, the minimized equations are evaluated. At the beginning, the circuit stays at state 0 as long as the input x0 is set to 1. When this happens, the circuit starts counting and shows the binary value of the state on the output. If the input is set to 0 again, the circuit holds the current state as long as x0 is set to 1 again. Another example is a binary counter which is able to count forwards or backwards. The approach of the design is the same as before. The first step is the state machine, the second step is the state table, where all unused states are marked as don't care expressions. And as the last step, the minimization of the circuit with K-maps. If now the clock signal is activated, the circuit starts counting forward from 2 to 5 and then starts again at 2. This cycle is running now as long as x0 is set to 1. If this happens, the circuit switches to counting backwards as long as x0 is set to 0 again.